Hello everyone and welcome to another video here on the Polaris School of Quantum in the Hidden Quantum Champion series. My name is Jonas and today we are looking again at a company from the quantum computing space. And now comes the exciting moment, drum roll, it's Eleqtron. Eleqtron, and now we are already at their website, Eleqtron with Q. So it says Magic, Zukunft of Quantum, so future of quantum. Quantum computing is the future and we at Eleqtron are already shaping it today. So let's try to figure out what they're actually doing by going, as always, through the website. So it says next generation quantum computing. Eleqtron develops and operates quantum computers. Our computing machines will be able to solve problems outperforming the best conventional supercomputers. To do this, we use the quantum states of ions controlled by established and miniaturized microwave technology, a unique concept we call MAGIC, magnetic gradient induced coupling. So that's magic. And I guess that's what the machine looks like. So very futuristic white box with a sleek design and just the label written on it. And now let's see what else we can learn here. So ready for the quantum revolution? Quantum computers will change our lives in many areas. They are capable of handling the most complex tasks quickly and efficiently. And they are far superior to even the best supercomputers when it comes to special problems. Calculations that today still take days, months, or even years can be performed millions of times faster with quantum computers. So powerful, user-oriented, and practical, worldwide unique technology, and pioneers in quantum computing. So what makes them powerful? Well, based on our MAGIC concept, which we learned about before, which is the microwave-based manipulation of ions, we are developing quantum computers specially tailored to solve commercial problems. The potential is huge since they enable enormous progress in a wide range of fields, from materials research, logistics, or supply chain management in industry to individualized products in the pharmaceutical sector to big data and risk management in finance. So quick note on this point. I know that people have a lot of questions like how exactly can a quantum computer be used, for example, in material research? Because as I learned, a lot of people also are interested maybe in the materials manufacturing space, watching this video and trying to understand, okay, how can quantum technology actually become interesting for my business area? Same for people from logistics and so on. If you are one of them, when you want to learn, for example, how quantum algorithms can be used or maybe in the future could be used for your business, also let me know down in the comments below. I'm very interested because I would actually love to go in, let's say do a deep dive on a specific problem case with you and just start at zero and learn, okay, how do we implement algorithms today? How will it be done, for example, with a quantum computer in the future? And understand this together. So if you have something very specific, like a very specific problem you would be interested in, let me know down in the comments below. We can make a video on this as well. But with that, let's hop back into the website. So it says, worldwide unique technology. Our qubits can be controlled with microwaves using the MAGIC technology. This is not only more precise, but also much more robust compared to laser control of qubits and, above all, excellently scalable. Then it says pioneers in quantum computing. As the first German commercial hardware manufacturer in the industry, Eleqtron is setting standards in the field of quantum computing. The international race for the industrial realization of the new technology has long since begun, and we are right at the forefront. And I mean, really, they are very much pioneering. So they are, as it says here, Germany's first commercial hardware manufacturer. So they were the first company to basically sell a quantum computer for use case to somebody, to some institution to actually work with that. And I think it's great to see these things happening in the landscape. I also managed, and maybe that also as a side note, I also managed to meet some of the employees at Eleqtron. We had a little chat about what they are doing, how things are going, and I really enjoyed it quite a bit. I really like the spirit that people have there, and I would really love to see that actually take even more, let's say, momentum and become successful as a commercial hardware manufacturer. Not only, of course, in Germany, but worldwide, because I think their systems, they're really interesting. They have a really cool edge to them with the magic technology. I also like their branding here, and I would love to see that move even further. But let's hop back to the website. Our goal is to make computing time on quantum computers available to companies, institutions, and science. Open bracket, hopefully also to education formats like this one here or the ones to come in the future, close bracket. So this is Eleqtron. At Eleqtron, expertise meets vision, funded in 2020 as a spin-off from cutting-edge research. The startup has since grown into a company comprising over 75 international experts with more than 50 million euros in order volume and strong investors at our side. We are shaping the future of quantum computing. Together with their team, Christoph Wunderlich, Michael Johanning, and Jan Leisse are making the quantum revolution a reality. Will you join us? And then here you see the founders, here you see the team, and there's the numbers that have been mentioned before, right? So different nationalities, investment, there's 16 million seed investment. And here I think we can also see something about the story of the company. So the quantum revolution, it's where we are at. So in 2012, first German quantum computer, first complete demonstration of the magic concept. In subsequent years, the focus shifted towards quantum algorithms. Then 2020, founding of Eleqtron. Eleqtron GmbH was founded on May 12, 2020, followed by the establishment of a strong team. Then first investment here. So the Eleqtron secured a 16 million euro seed investment led by renewed VC firm Early Bird. And then on the first and 2023, we have the first major order, sale of quantum computers within the scope of QC project to the German Aerospace Center, DLR. And we can even go on here. Second location, opening of an additional office in Hamburg, featuring strong local experts, and then further major orders, sale of quantum computers to Forschungszentrum Jülich. We have seen that name already before in this series as part of the HIQ project for integration into the Jülich supercomputing cluster. And then, okay, what else do we see here? So shape your future with us. Here are some opportunities and open positions. And then there's also a possibility to learn more and get in touch with them. With that, we scroll back up all the way up to the website. And we can look at the product part of it. So here we see the quantum computer, as mentioned. First one has already been sold. Second one is going to Jülich, right? So quantum computers from Eleqtron. Our quantum computers are ready to change the world, freely programmable, scalable, and available for industry and science. The potential application of quantum computing are huge, but to use them, reliable technologies and the courage to break new ground are needed. We bring both to the table. As the first German quantum computer manufacturer in Germany, we've already made computing time on ion-based quantum computers available. Then we see here the innovation approach. Quantum computers will solve problems that are currently unsolvable. Unlike conventional bits of a regular computer, the qubits of a quantum computer can assume combinations of the state 1 and 0 simultaneously. This ensembles parallel calculations and makes quantum computers incomparably fast and efficient. Supercomputers can't keep up with them. Mission magic, so magic again as the magic principle, right? For more than 20 years, researchers have been trying to develop scalable quantum computers that make advantage of quantum effects. Open bracket, I've been observing this now for more than 10 years already. So probably half of the time I've been looking at this, and I can definitely say it's been an exciting journey. So I think maybe when I started in the lab, I think we had in this specific case, in the specific part that I was working in, we had 2 qubits, and it was already very exciting. And now there's so much has happened, and I'm really much looking forward for the next 10 years to come. Hopefully there's at least the same amount of development happening. In the process, however, they're encountering new challenges. The biggest difficulty is shielding and controlling the qubits. They must be isolated from the environment by an elaborate process, which, depending on their architecture, places enormous demands on cooling and controllable environments. Precise control of the quantum states generated is also difficult to master. And I mean, that's kind of also a trade-off, right? Because on the one hand, you need to isolate the system because we are operating on a quantum level, right? So if we, for example, look at energy, a quantum jump from one to another level, so from 0 to 1 state, for example, is by definition the smallest energy separation, right? It's a quantum state transition. That means every type of influence from the outside that can, let's say, excite the system, put a little bit of energy in the system, can already destroy the quantum state. That's why you have to shield it so well. Now, if you shield it, think about, for example, think about a bank. You have your money, let's say cash or gold coins or whatever, and now you want to make sure that they are safe, right? So you will protect them. You put them in a safe with very thick walls around it, guards around it, whatever. But then, of course, they're sitting there, right? Now they're in this location, sitting somewhere behind some metal walls with guards around it, whatever. And you cannot just access them. So you cannot go for grocery shopping and just spend them, right? And the same is true for these quantum systems. You want to protect them, so you create a very good shielding around them, you protect them, but then of course you also need to interact with them somehow. You want to tweak them from 1 to 0 operation and vice versa, so you still have to be able to somehow also move them in a very controlled way, and that is kind of, it always ends up in some way into a trade-off, and figuring out a system that on the one hand is very well protected and isolated, and on the other hand can be very precisely controlled. That's kind of the phase which we are in right now. That's where we benchmark different quantum systems against each other, or trying to figure out what is the right way of benchmarking them. But okay, close bracket, right? So, an ion-based quantum computer with magic. Our unique magic technology is a true milestone magic. Magnetic gradient-induced coupling enables us to control ion qubits with microwaves. Precisely, reliably, and inexpensively. Microwave fields are already ubiquitous in computers, and cell phones measurable and perfectly controlled. Individual control of qubits can be integrated into trapped chips, and can be done with unparalleled quality. We have already been able to demonstrate a control with our magic technology does not exert any undesirable side effects on other qubits, thus significantly reducing a major source of error. The laser cooling as well as the readout of the quantum bits can be performed with much simpler lasers. Commercially available, robust and proven technology is used to control them. In principle, scaling up to more ions will pose no problems either. Miniaturized structures for trapping ions and controlling qubits can be integrated on chips. And I think that's what we are seeing right here. So this is one of these, let's say, ion trap chips, I would guess. So what we see here is we have these black lines here. These are, I guess, the connectors. So you have some way of connecting from the outside electrically to the chip. Here you have, I guess, the chip might be silicon, might be something else. I don't know. I would guess it's like a silicon crystal. And then on top of that, like on top of the crystal, we see these patterns here, these structures. These are what I would guess some type of metal gates, so some type of metal structures. Now, if you apply a voltage to them, you create an electric field, or if you change the voltage, you create a magnetic field also, because currents are flowing. And with this electromagnetic field, you can actually trap ions, because ions, they are atoms where you take away one electron, so they have like a positive charge to them. That means with an electric field, you can actually move them around. Because if you apply, let's say, a negative field here and you have the positive ion here, it will be moved towards the electrical gate, for example. And then, of course, if you would, for example, apply varying gates, like you would start to shake the ion, so you can also move it, you can manipulate it, do things with it. And then on top of that, you have this laser, I guess, here. So there's a laser beam, and with that, as mentioned here, you can do some operations, read out, and so on. Cooling laser as well as readout. Okay, so here we see the actual chip, I guess. That's what it actually looks like in reality. It's also nice to see that this is something which you can still very much optically see. So you can see that this is like, I guess, some recording with a magnifying glass or microscope lens, but you don't really need, let's say, a scanning electron microscope. So these structures, they are still visible. It's not like they are extremely tiny. They are tiny, but they're not, let's say, at the limit of tiny, as in what we are seeing with processor chips, right, of today. Then there's some optics components here. We see Tor Labs, which I think has already been featured in another video. If not, this is a spoiler now. And then let's quickly go through this. So welcome to the future, quantum advantage, the point at which quantum computers become definitively superior to supercomputers in practical applications. While many see this as a distant future, at Eleqtron it's already within reach. To bring our freely programmable magic quantum computer to the market, we drive forward daily developments in ion trap chips, microwave technology, and quantum algorithms. Already today, we are implementing quantum computers to address relevant real-world problems. The technology is ready, and so are we. And then, okay, we see here quantum computers in action. So now we come to, I guess, the algorithm part. With our Magic App funding project, among others, we are paving the way to the industrialization of quantum computing. Potential applications range from medicine to finance and far beyond. So we have optimization, search algorithms, chemistry and biology, cryptography, logistics, and machine learning, which are, again, candidates that we've also seen in other videos. If you haven't seen those, make sure to check out our playlist on the other hidden champions. With that, we move on. So the full potential of quantum computers can hardly be estimated today, but one thing is clear: as technology advances, so do the possibilities and needs. Grow along with us. And then, okay, our goals, our mission: we build scalable solutions for tomorrow's quantum computers, collaborating with our partners to enable the development of groundbreaking solutions for today's and future potential challenges. The first Magic quantum computers are already operational. We are continuously working on further machines with progressively increased performance and integrating them into the cloud. Our big goal is to bring a scalable and freely programmable Magic quantum computer to the market. And then there's some frequently asked questions down here, and again, an opportunity to get in touch with them. As always, we also check out quickly the company, so we learn a little bit more about the company. Here we see the founders again from before. It says we are Eleqtron. With our disruptive technologies, we bring quantum computing from research to application. We open up new markets and pave the way for tomorrow's innovation today. Together, we rise to every challenge and put our heart and soul into our mission. Together, we make decisions, celebrate our successes, and as a strong team, shape the technologies of tomorrow. One team, one goal, infinite possibilities. Here we see the team again, founder and CSO, CTO, and the CEO. Then it says our international team of researchers and business professionals has stepped up to fundamentally change the future of quantum computing. And again, there's an opportunity to apply here. Know-how meets visions. As a spin-off of the quantum optics chair at the University of Siegen. Our team at Eleqtron works towards an ambitious goal: developing a freely programmable, scalable quantum computer. Our international team of technology, product, and business experts is here to fundamentally transform the future of quantum computing. With our unique magic technology, an order volume exceeding 50 million, and a strong investor backing us, we already hold the key to success. There's some partner information here, and again, an FAQ with frequently asked questions. And I think with that, we already got a very nice overview on the company Eleqtron with Q in the Eleqtron. And I hope you liked the video. If so, please give it a thumbs up and make sure to subscribe to not miss out on another one. I'm looking forward to see you again here on this channel. And then, well, see you in the next video. Bye-bye.